Jinyuan A-series bending machine basic usage tutorial. First, put in the sheet metal. Manually pass the board through the straightener. Use the encoder meter wheel until it reaches the bending outlet, ensuring flatness and smoothness. Put down the feeding block and lock the position. Put down the machine arm and lock the position. Finally, adjust the straightener appropriately. Preparation work completed. The first step is to install software and drivers. Insert AU disk. Copy files from the U disk to the computer desktop. Select all, unzip to the current folder. Open the software installation package. Select a disk other than the C drive as the installation path. According to the prompt, click Next to complete the installation. Open the driver installation package folder. If it is an XP system, please select ADT201-8107 for installation. If it is a Windows 10 or Windows 7 system, please select SH8640 A1 driver installation. Open compressed file. Select files with EM characters. Double-click to open for installation, click Next. Attention, the driver installation disk should be consistent with the software path. Click Next according to the prompt to complete the installation. Open the software. Click Language in the menu bar to switch to other languages. Software and driver installation completed. 2. Parameter copying. Find the data folder, which is the basic factory parameters of the machine. Copy this folder. Right-click the software icon, open the file location, paste it, and select the file in the replacement target. Parameter copying completed. 3. Material setting. Click Parameters in the menu bar, then click Material Settings. Built-in multiple board parameters for selection. The letter SS is an abbreviation for stainless steel in English. 201 and 304 are material types. The last digit is the width range of the board. ALFT, aluminum flat. GS, galvanized sheet. ALEX, aluminum exclusive. CJZ is a super ladder, FR is a regular model. HMT, channel loom. Based on the specifications of the processed board, select the corresponding board classification. In the sub-board material library, you can add profile, edit profile, delete profile. Select Add Profile and create a name. Select the mark thickness for the board and enter actual thickness. Select slotting type. Stainless steel and galvanized sheet must be slotted with a planar blade. Other parameters can be kept as default and modified as needed. Click Save. In the Materials Options panel, switch sheet categories. Select the name of the newly created board. The pop-up prompt shows that the current slot type is planar. Click Confirm. If the processed sheet metal is aluminum flat plate, aluminum profile, or channel loom, it must be reclassified according to the current sheet metal. Pop-up prompt, current slot type, cutter. At this point, it is necessary to remove the planer before processing. If it is necessary to switch to slotting with a planer again, the process of replacing the planer must be carried out once. 4. Change cutter. Click to change, enter the current material thickness, and click Confirm. According to the pop-up prompt, remove the planer. Click OK. Install the planer according to the pop-up prompt so that the planer touches the surface of the material. Click OK. Lock the planer. Click OK. Planer change is completed. Five. Adjustment of slotting stroke and depth. The slotting stroke can be understood as the lifting height of the planer or milling cutter. Click Slot Test and observe the lifting height to see if the board can be fully slotted. If incomplete or too high, change the front slotting trip. Click the slot test again until the slot is completely opened. Change the slot base depth. The smaller the number, the deeper the slot. Click the slot test. Repeat the operation until the depth is appropriate. Change the cut base depth, dime base depth to be the same as the slotting base. Click Save Material Parameters. It is recommended to adjust the slot depth of the milling cutter from 0. Unlike a planer, the larger the number, the deeper the slot. Change cut base depth, dime base depth, and slot base depth to be the same. Click Save Material Parameters. Slotting depth debugging completed. 6. Feed calibration. Firstly, send the board out of the cutting edge. Make a starting mark at the cutting edge position. Click Parameters in the menu bar, then click Feed Calibration. Click Start Calibration. Click Yes. Wait for the feeding to stop before marking the end. Click Yes to measure the length between the markers. Click OK and enter collection length. Click Confirm Calibration, then click OK to close the window. Next, let's conduct the test by marking the starting point. Check step and change the parameter to 2000 mm, then click Material Feed In. Make end marks and measure the length between the marks. Click Tools in the menu bar, then click Calibration Adjustment. Ensure that the feeding length is 2000 mm. Change the actual collection length and click Calculate. Please note that you can only click Calculate once. Click Save. Delivery calibration completed. 7. File picking. Right-click the workspace, click Open, select the file that needs to be processed, and click Open. The mouse wheel can control the shape to zoom in and out around the arrow for viewing. Hold down the left button and move the mouse to drag and view. Right-click the workspace. If processing a bounding box, select Outer Picking. Double-click nodes in the graph to select all graphs. If processing the inner, choose Inner Picking. If you choose the wrong option, you can click Undo Picking. You can choose the path of one section of the graph or manually add nodes. After selecting the shape, click Confirm Picking. Click the Start button to start processing. It should be noted that manually added nodes are equivalent to slotting points. When selecting graphics, they will still be retained. Click Delete Nodes. Select the node and press Delete to delete it. (8) Bend knife calibration. Click the parameters in the menu bar, then click Bend knife calibration. Firstly, adjust the left bend balance. Inner picking bending balance arc section. Confirm picking and start processing. Observe and compare the curvature if it is inconsistent with the shape. Change left bend balance. The larger the value, the greater the impact force, and the smaller the value, the smaller the impact force. Repeatedly test until the curvature matches the shape. Right bend balance requires outer picking the shape. Confirm picking and start processing. Change the value of right bend balance. Repeatedly test until the curvature matches the shape. Next, debugging bend force. Inner picking bending force arc section. Confirm picking and start processing. Change left bend plus until the curvature matches the shape. Outer picking the shape, debugging right bend plus until the curvature matches the shape. Save the parameters of the board and complete the calibration of the bending knife. The basic usage tutorial is over. Thank you for watching.